Unit 7, Day 3 introduces the concepts of sine, cosine, and tangent values. Now we abbreviate sine as SIN, we abbreviate cosine as COS, and tangent as TAN. If you look at any calculator, you'll see 3 buttons on your calculator. One says SIN, one says COS, and one says TAN. Sine, cosine, and tangent. So right now, I want you to go into your calculators, and your calculators need to be in the degree mode, all right? Not the radian mode. To check that, if you've got a TI-84 Plus, click on the word mode. It's in all white, and you're going to go down, and you'll see either radian or degree. Make sure degree is highlighted. Now in the ALEKS calculators in the ALEKS software, you don't have to do anything, it's already set up. You'll see your sine, cosine, and tangent buttons. All right, so I'm going to use the ALEKS calculator. I want to know the sine of 31 degrees, the value of sine 31. So I click sine, and then I put in 31 for degrees, and then I hit equals. And I'm going to get a really long number. And it is 0.51503, 0.51503, ... I'm going to round to the nearest hundredth. You know the routine. Underline what you want. So it is 0.52. Now let's find cosine. You've got to clear it. Cosine of 77. Same concept. Just click cosine, not COS with -1. That's the whole different unit. Okay, this is 0.23. And the tangent of 8 degrees, 0.14. Okay, you can get that from your calculator. Your phone calculator, if you've turned it sideways, regular TI-84, any of those, it's on the buttons in the ALEKS calculator. Now we do things with sine, cosine, and tangent. They're ratios. The sine of an angle is the opposite leg over the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse, and the tangent of the angle is the opposite leg over the adjacent. You're saying what angle? That's where we use theta. That symbol that I just circled is called theta. So if I want to know the sine of theta, I will look at the opposite leg, which would be this one I just drew in red, and put that over the hypotenuse. Now the hypotenuse will never change. Doesn't matter what the angle is. The hypotenuse in a right triangle is always the same. But opposite and adjacent legs do change based on the angle you're using. Adjacent means it's part. It's one of the rays of that angle. So now let's do some numbers, and let's put this in practical. Okay, you've got a right triangle, has side lengths 5, 12, and 13. By the way, that's called a Pythagorean triple. Just letting you know that's a special one. You use these lengths to find the cosine of A, the tangent of A, and the sine of A. All right, sine is, here's our memory device, SOHCAHTOA. Sine, S-O-H. Sine is opposite over hypotenuse. I'm using the sine of angle A. The opposite side is 5, and the hypotenuse is 13. Now I'm still going to use angle A, but now I'm going to find the cosine, and that is the adjacent side over the hypotenuse. Now look at this. We've got 2 adjacent sides, right? Because every angle has 2 sides. Well, the hypotenuse will never be called the adjacent side. It is always the hypotenuse. So the adjacent side will be 12 over 13. In fact, I'm going to write so we can start learning it. 13 is always going to be the hypotenuse. Hypotenuse. I think I spelled that right. Okay, for angle A, this will always be the opposite. And for angle A, this will always be adjacent. All right, that way you know. Everything is in terms of angle A. So the cosine of angle A is the adjacent over the hypotenuse, the A over the H, which is 12 over 13. And the tangent of angle A, of vertex A, is the opposite over the adjacent, which is 5 over 12. We do not expect you to do anything else with that. We do not expect you to do the math. We want to see the ratios, so leave it as a ratio. That is exact. Okay, now let's do another one. We're looking for C, so I'm going to circle C. This is still the hypotenuse. This is opposite. And this is adjacent. You do not have to label your triangles, but if you're trying to remember what the names are, it's a helpful skill. The sine of C, sine is opposite over hypotenuse, which is 6 over 10, which reduces to 3 over 5. Cosine C is adjacent over hypotenuse, which is 8 over 10, which reduces to 4 over 5. And tangent is opposite over adjacent, which is 6 over 8, which reduces to 3 over 4. And there you go. That gets you for your very first use of sine, cosine, and tangent. We'll practice this a little bit more. Now we're going to do it in terms of A, B, and C. There are no numbers. You're doing it in terms of A, B, and C. So I'm not going to mark up the triangle. You can mark it up if you wish. Sine A, so opposite over hypotenuse, which would be A over B. Cosine X is ca, adjacent over hypotenuse, which is C over B. And tangent X is toa, opposite over adjacent, A over C. All right, now you try one. The math isn't difficult. It's just making sure you understand how to set it up. We're doing sine B. All right, I'm not even going to put letters. We're just going to do the answers. Sine B. B over C. Cosine of B, A over C, and the tangent of B is B over A. Don't try to memorize letters. Understand and learn what opposite and adjacent mean in relation to that angle. And that gives you the basics. Part 2 of this assignment is using what you've learned about trig ratios to find side lengths in a triangle. All right, keep in mind, and the more you write it, the better off you're going to be. You got sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So, ka, toa. I promise you, all your math teachers learned it this way. We haven't forgotten. So now let's use this to find the missing side length. Look at the triangle you have and look what you know. You have this angle right here. We'll call this is our theta. You have this side, which is the adjacent side, and you have this side, which is a hypotenuse. So you're going to use the trigonometric ratio that goes with the information you have. And cosine is adjacent over hypotenuse. That's why we want the cosine of 52. So the cosine of 52 equals x over 15. Cross multiply and solve. Well, I'm going to write it all out here. We put that as cosine 52 over 1 equals x over 15. It's easier to do a ratio, or rather to cross multiply when you have two fractions. So let's cross multiply. We have 15, I'm sorry, not 15, 5. Wow, that's going to change our answer, won't it? Let's get rid of that. Let's get rid of that. Sorry, guys. And let's get rid of, I can't cover it up, but I typed it in incorrectly. There we go. Get rid of it on the paper. So cosine 52 is x over 5. So I'm going to cross multiply. I have 5 times cosine 52 equals x. And this is where you use your calculator. You actually do punch in numbers. 5 times, well, it helps if you put in 5. 5 times cosine 52 equals 3.07. Let's see. 8307. And we are looking for the nearest tenth, 3.1. And that is the length of x. So it's actually not hard. It looks very complicated, especially when you have cosines and x's and stuff. All you're doing is what you did way back in Algebra 1. You are setting up a proportion and you are cross multiplying to solve. Not a big deal. Let's go to the next one. Now, you got to do a little more work. We are telling you which trigonometric ratio you want to find, but you have to fill in some missing gaps on your triangle. So let's look. We want sine theta. Remembering, sine is opposite over hypotenuse. Do we have the hypotenuse in this triangle? We do not. So how do you figure it out? You have to use the Pythagorean theorem. 7 squared plus 24 squared equals h squared for hypotenuse. Actually, no, I'm going to make that c, since we call the hypotenuse c all the time. C squared. Let's do the math. 49 plus, pause, look at my calculator. All righty, 24 squared is 576. Equals c squared. 625 equals c squared. What is the square root of 625 equals c? What is the square root of 625? 25. How awesome is that? So now we have the measurement for our hypotenuse. Now we need the sine. Sine theta is opposite over hypotenuse. There's theta. Opposite is 24. Hypotenuse is 25. And we leave it like that. That is your exact answer. When we leave it in a fraction, that is an exact answer. So actually, there it is. And there's all the work. 24 over 25. This is far easier than it looks. You're applying concepts you've already learned. Excellent, guys.